everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW English class 9th and 10th and to your Phoenix batch. So in this particular video, we are going to start with a very new chapter and we are going to cover it in one single shot, and that is quadrilaterals. So we are going to start with the theorems, what all is involved, what all type of quadrilaterals are there and what are their properties. So this is something that we are going to learn in this particular lecture. So let's start with it. So the very first thing that we have is today's target, that what we are going to cover today. So we are going to start with the introduction to the chapter, the angle sum property of quadrilateral, types of quadrilateral, then properties of parallelogram, midpoint theorem and some important questions. So let's start with the quadrilateral, people. So whenever we hear the word quadrilateral, it simply means that it is a simple polygon with 4 sides. We know that a polygon simply starts with 3 sides, that is a triangle. If it's 4 sides, then it's a quadrilateral, 5 is a pentagon, 6 is a hexagon, and so on. So quadrilateral is a figure, is a closed figure basically, which comprises of 4 sides. Now we know a lot of shapes which has 4 sides. For example, a square, rectangle, rhombus, kite, parallelogram and all other things. So all these are quadrilateral with 4 sides. Now let's learn about the next thing, that is angle sum property of quadrilateral. So what is angle sum property of quadrilateral means? That the sum of all the 4 angles of quadrilateral. For example, if I add all the 4 angles, that is angle A plus angle B plus angle C plus angle D. So all the 4 angles of this quadrilateral adds up to 360 degree. So this is the angle sum property of a quadrilateral, which means that the sum of all the angles of a quadrilateral is equivalent to 360 degrees. The next thing that we have is types of quadrilateral. Now there are some general properties for types of quadrilateral. When we talk about types of quadrilateral, it means different names that are given to different quadrilaterals depending on what all properties they exhibit. For example, the very first is square. We know that all the sides of square are equal, all the angles are 90 degree, the diagonals are equal to each other. So these are the properties of square, and that's why it is named as square. The second one which we have is a rectangle. Rectangle, the opposite sides are equal, all the angles are 90 degree, the diagonals are equal, right? So these are the properties of rectangle. The next we have is a kite. So in kite, the adjacent sides are equal to each other. The next we have is a diamond. So diamond has all 4 sides equal. The next we have is a rhombus. Rhombus also has 4 sides equal and its diagonals bisect at 90 degree. The next we have is a parallelogram. The opposite sides are equal, adjacent angles are supplementary, opposite angles are equal, and opposite sides are parallel and equal to each other. So these are certain properties and all these properties are written down, right? What is trapezoid? Trapezoid is again where we have 4 sides, out of which 2 are parallel and 2 are non-parallel sides. Now these are the property. Let's start reading about it. So when we talk about square, bacha, opposite sides are parallel, right? Opposite sides are parallel to each other, all the sides are equal to each other, and all the angles are right angles. When we talk about rhombus, opposite sides are parallel, all the sides are equal, opposite angles are equal, and diagonals bisect each other at 90 degree. When we talk about rectangle, opposite sides are parallel and equal and all the angles are right angle, that is 90 degree. The next we have is parallelogram. Opposite sides are parallel and equal and opposite angles are equal. Adjacent angles are supplementary as well. When we talk about trapezoid, 1 pair of opposite sides is parallel, and when we talk about kite, 2 pairs of adjacent sides are equal, 1 pair of opposite sides are equal. Then we have all the properties. Now, the next thing that is important in this chapter are the theorems. Now, let's learn about each and every theorem one by one. Theorem 1 says a diagonal of a parallelogram divides it into 2 congruent triangles. Now, what does this mean? That if we have a parallelogram and in this parallelogram, if I draw a diagonal, that means from one end to the other opposite end. So, we know that if I join any 2 sides, any 2, not the adjacent, But if I draw a diagonal in a quadrilateral, it divides the quadrilateral into two triangles, right? Same in case of parallelogram, as you can see, there are two different triangles. But over here, there is a new thing that we have is the diagonal of a parallelogram divides it into two congruent triangles. That means this triangle will be exactly equal to this triangle. Both of them will be congruent to each other. The next thing that we have is in a parallelogram, opposite sides are equal. This is again a property and we can also prove this. The next theorem we have is if each pair of opposite sides of quadrilateral is equal, then it is a parallelogram. It's a converse of it. If the opposite sides are equal and parallel, it's a parallelogram. Square is also a parallelogram. Rectangle is also a parallelogram. There are types of parallelogram, right? The next thing that we have is theorem 4. In a parallelogram, opposite angles are equal. So if we have a parallelogram, bacha, for example like this, so this angle will be equal to this angle and this angle will be equal to this angle. The opposite angles of a parallelogram are equal to each other. The next thing that we have is if in a quadrilateral each pair of opposite angles are equal, then it is a parallelogram, converse of the previous theorem. The next theorem that we have is the diagonals of a parallelogram bisect each other. That means what? If we have a parallelogram, right, and if we simply draw the diagonals, for example this and this, so they bisect each other means that this part will be equals to this part and this half will be equal to this half. This is what bisection means. Next we have if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. The same way, converse of the previous theorem that we have just read. Now, from the question it says, the angles of a quadrilateral are in the ratio 3:5:9:13. Find all the angles of quadrilateral. So, whenever the ratio is given to us, bacha, what we do? We always remove the ratio and write down x for that unknown multiple that we have. So, let's say first of all we have to write let the angles be 3x, 5x, 9x, 13x. Right? So, we have removed the ratio and when we have removed the ratio, we have just put the x. Now, when we have this x value, what we do? We know that the sum of all the four angles of a quadrilateral is equivalent to, the sum of all the four angles is equivalent to 360 degree. As simple as that. We know that sum of all the angles of a quadrilateral is 360 degree. So, simply we have to add this up. That means 3 plus 5 plus 9 plus 13 will be 30x, right? So, 30x will be simply 360 degree and from here we have x is equals to 360 by 30 and we can simply say that the value of x is equivalent to 12. So, from here we got the value of x simply as 12, right? So, this is how we do it. This is how we find it out and it is as simple as that. Now, simply, so if we have 3x, this simply means 3 into 12, that is 36. If we have 5x bacha, that simply means 5 into 12, that is 60. If we had 9x, that simply means 9 into 12 and this will give you 108 degrees. And if we have 13x, so this simply means 156 degree, that means 13 into 12 and this will give you 156 degrees. So, this is how you solve for all the angles if the ratio is given to you. I hope that this thing is clear with everyone. Now, let's move forward to the next question. Right. The next question says, show that the diagonals of a square are equal, bisect each other and at right angles. Now, what does the question ask you to show that the diagonals of a square are equal? The very first thing, the diagonal of a square are equal. The second thing that the question expects you to prove is the diagonals bisect each other, and then the third thing, the diagonals bisect each other at 90 degree. So, let's start with the very first proving that the diagonals are equal. First of all, let's name our square as A, B, C and D and let's name the center as O. Alright, so this is our square and let's start with the very first proving that the diagonals are equal. Basically, we have to prove that AC is equals to BD. Now, to prove such type of questions, bacha, we need congruency. So, if we have to prove AB equals to CD, which triangles we are taking? ABC and BCD. So, in triangle ABC and BCD, what all do we have, bacha? In triangle ABC and BCD, first of all, AB will be equal to CD. Why? Because it is the side of square. Next, 90 degree, because we know that all the angles of square are 90 degree. So, this will be equal to this angle, right? So, basically we can say that angle B is equals to angle C, both being 90 degree. And the next thing that we have is BC equals to BC, that is common. So, by SAS congruency, both the triangles will be congruent and we can simply write that AC is equals to BD by CPCT. Congruent part of corresponding triangles are equal. I hope this thing is clear with everyone. How we did that? AB is equals to CD. Why? Because they are sides of square. BC equals to BC. Why, bacha? Because it is common. Now, the next thing that we have to prove is that the diagonals bisect each other. So, we have to prove that AO is equals to CO and BO is equals to DO. Now, to prove that, we need to take two other triangles and prove them congruent. That is AOB and COD. Now, in triangle AOB and triangle COD. Now, we have two triangles, that is AOB and triangle COD. Now, how do we prove the congruency, bacha? First of all, AB is equals to CD. Again, the same reason, because they are sides of square. Right? Sides of square. As simple as that. Okay. Which triangle have we taken? We have taken AOB and we have taken COD. Alright. Square is also a parallelogram. We know that. Right? Also, we know that DC will be parallel to AB. Right? If DC is parallel to AB and if we take, let's say, CA as transversal, so this angle will be equal to this angle, alternate interior angle. So, we can say angle OAB will be equivalent to angle OCD. And why we can say that, bacha? Because they are alternate interior angles. The next we can say is AOB is equals to COD, vertically opposite angle. Angle AOB is equivalent to angle COD and they are vertically opposite angles. So, we can say by AAS criteria, both the triangles will be congruent and then we can say AO is equals to CO, AO is equals to CO and BO is equals to DO. BO is equals to DO by corresponding parts of congruent triangles. By corresponding parts of congruent triangles. Now, the third thing that we have to prove is that they bisect at 90 degree. What do we have to show? That they bisect at simply 90 degree. Right? Now, what we can say, bacha, over here, see, first of all, try to understand that by this point, we have proven everything that we need. Okay? We have proven everything that is needed. First of all, that it's simply the diagonals are equal. Secondly, we have proven already that the diagonals bisect each other. So, we know that AO is equals to CO and BO is equals to DO. Now, to prove that the diagonals bisect at 90 degree, we have to show that this angle is basically what 90 degree is, right? So, which two triangles we need? These two triangles now in this case. So, now triangle AOB and BOC. Now, in triangle AOB and triangle BOC. So, what we can write, bacha? First of all, AB is equals to BC. AB is equals to BC. Right? Sides of a square. Then we can say BO is equals to BO, that is common in both the triangles. BO is equals to BO, that is common. Next we can say that AO is equals to CO, as we have already proven. So we can say that AO is equals to CO from this part. So by triple S congruency criteria, both the triangles will be congruent, and we can say angle AOB is equals to angle BOC. Angle AOB is equals to angle BOC by CPCT. Now, we can also see that AOB and BOC are forming on a same straight line. And we know that angles on a same straight line forms a linear pair. So, this will be equivalent to 180 degree. That means twice of angle AOB is equals to 180 degree, and angle AOB bacha will be equals to 90 degree. That will also be equals to angle BOC. So we have proven all the three parts that were asked in the question to prove the diagonals are equal, to prove that they bisect, and to prove that they bisect at 90 degrees. So I hope that this thing is clear with everyone. Now let's move forward and see the next part. Okay. Now in this question, the very first part is show that APB, right, is congruent to CQD. Now see, quadrilateral includes your congruency, that is triangle part. So we have to show that this ABP triangle is congruent to this triangle. Alright, and it is given that ABCD is a parallelogram. Now the very first thing is it is given that ABCD is a parallelogram. So we know that AB is equals to CD. What triangles we are taking? We are simply taking in triangle APB and triangle CQD. The very first thing is the properties of triangle, and what is the property of triangle? That the opposite sides are equal. And if opposite sides are equal, then AB is equals to CD, as simple as that. Right? The second thing that we have is, if this is 90 degree bacha, this should also be 90 degree because the outer one is 90 degree. So we can say that angle APB is equal to angle CQD, both being 90 degree. Right? The next thing that we can say is, if it's a parallelogram, right? This is simply a parallelogram, and it divides the triangle into two congruent triangles. We have learned the theorem, right? What about the theorem? First of all, see what we have to show. See, this and this triangle APB and CQD. This one over here is Q. Alright, so we know that the diagonal divides the triangle into two congruent parts, right? Now for two congruent parts, what do we have? For two congruent parts, we have that the heights of both the triangles are equal. If there are two triangles that are congruent, right? So we know that height of both the triangles will be equal as well. So we can write down CQ is equivalent, right? CQ is equivalent to AP. So CQ is equivalent to AP. So what we have taken? This angle, we have taken this side and this side. So which congruency criteria, bacha? By RHS congruency criteria, we can say that both the triangles are congruent to each other. The next thing that we have is AP is equals to CQ, right? Similarly, what we can say that AP is equals to CQ. The one more thing that we can also use, right? If you don't want to show that AP is equals to CQ throughout, because for AP equals to CQ, you have to write down the diagonal of a parallelogram divides it into two congruent triangles, and both the congruent triangles have equal heights. If you don't want to show that, you can simply say that CD is parallel to AP, and this angle will be equal to this angle. Which angle? Angle CDB, or we can say from here ABP is equivalent to angle CDQ, right? CDQ and APB are equal. Why? Taking AB parallel to CD and BD as transversal. So now what we can say, which we have taken this angle, we have taken this angle and this side. So we can now prove it by AAS congruency criteria. Right, and as the second part itself says that AP is equals to PQ, so we can simply write that AP is equals to CQ by CPCT, that is corresponding parts of congruent triangles. I hope that this thing is clear with everyone. Now let's move to one other major important thing that you will be studying in this particular chapter. So we have midpoint theorem, bacha. And midpoint theorem in this chapter is really very important. Really very important in terms of when we talk about midpoint theorem, that simply means we are talking about questions and varieties. So you need to understand what is midpoint theorem. So midpoint theorem says the line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it. Now what does that mean? Let me tell you. For example, beta, if we have a triangle, right? This is triangle A, B and C. Let's say D is the midpoint of AB and E is the midpoint of AC. We have a triangle ABC and we have taken that let this D point be the midpoint of AB and E point be the midpoint of AC. Now what can we do, bacha? Simply if I join this line, so if I join this line, so this line will be parallel to the third side and also be half of it. That means I can say that DA is parallel to BC and also DE is equivalent to half of BC. So this is how we do it. So let's see how and what type of question before starting. The line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. The converse of midpoint theorem. I hope that the theorem and the statement is clear with you people. Let's see how we apply it. Now the very first question is, in this triangle ABC, DEF are respectively the midpoint. So what is given to us? That D, E and F are respectively the midpoints of the triangle, right? Now we have to show, so midpoints of AB, BC and CA, we have to show that ABC is divided into congruent triangles, four congruent triangles, that if we say that DEF, if we join all the 3 points, now we can see there are 4 triangles in this picture. What are 4 triangles, bacha? One is this one, the second one is this, the third one is this and the fourth one is this. So we have to prove that all these 4 triangles are congruent to each other. Okay. First of all, beta, if we say in triangle ABC, D and F are the midpoint. Okay. If I say that in triangle ABC and I am taking D and F to be the midpoint. D and F to be the midpoint. So we can say that DF is parallel to BC. What we can say? That DF is parallel to BC. If in next thing, if I say that in triangle ABC, if I take EF as midpoint. Now in triangle ABC, if I take E and F as midpoint. E and F as midpoint. Right? So what we can say, if E and F are midpoint, so EF is parallel to AB. We can say that EF is parallel to AB. How are we saying that? Look at the figure. If I say that this is the triangle, D and F are the midpoint, so DF is parallel to AC. One thing, right? If I say that in this triangle ABC, E and F are the midpoint. Again in this triangle ABC, E and F are the midpoint. So this EF will be parallel to the next side. Similarly, if we are taking triangle ABC and D and E are the midpoints, so DE will be parallel to FC. So 3 conditions we can take, right? So simply we will be writing that again in triangle ABC, if I take D and E as midpoint, D and E as midpoint, so we can say that DE is parallel to AC. Now see, From the first part, if DF is parallel to BC, but look at this figure very carefully. If EF is parallel to BC, or let's say if DF is parallel to BC, let's take DF parallel to BC. If DF is parallel to BC, so DF will also be parallel to BE. Yes or no? Right? If this whole line is parallel to this whole line, so DF will also be parallel to BE. Similarly, if EF is parallel to AB, so EF will also be parallel to DB. So what we can write over here? We can simply write over here that if DF is parallel to BC, so DF will be parallel to BE as well. And from here, if EF is parallel to AB, which implies EF will be parallel to BD as well. Right? EF will be parallel to BD as well. This thing clear? Now see, in this figure, DF is parallel to BE and DB is parallel to EF. So from both these statements, bacha, what we can say? From both these statements, we can say that DFEB is a parallelogram. We can say that DFEB is a parallelogram. If DFEB is a parallelogram, so ED is a diagonal, right? DF is a parallelogram, which implies DE is a diagonal. And we know that a diagonal of a parallelogram divides the parallelogram into two congruent triangles. So from here we can say that triangle DBE, right? From here what we can say that triangle BDE is simply congruent, right, to triangle FED. Right? Now again, if we don't consider this, we know that DE is parallel to AC, so DE will be parallel to FC. DF is parallel to BC, so DF will be parallel to EC as well. So from here now we get this as a parallelogram. So similarly, now what we can write? We can write similarly, DECF is also a parallelogram. So again, this triangle will be equal to this triangle. Let me name this. This is triangle 1, this is 2, this is 3 and this is 4. So from here what we can simply say that triangle 1 is congruent to triangle 2. From here we can simply say if DECF is also, so we can say that triangle 2 is congruent to triangle 3. And if we take for example this is 1, 2, 3 and 4. Now if we take bacha this ADEF as parallelogram, the first parallelogram was this one, the second was this orange one and the third one is this green one. So these are the three different parallelograms that we have taken, and from that part we can say similarly DEFA is a parallelogram. DEFA is also a parallelogram, right? And if DEFA is a parallelogram, then triangle 2 is congruent to triangle 4. Now see, triangle 1 is congruent to triangle 2, triangle 2 is congruent to triangle 3, triangle 2 is congruent to triangle 4, which means triangle 1 is congruent to triangle 2 is congruent to triangle 3 is congruent to triangle 4. And this is what we had to prove in this question. I hope that this question is absolutely clear with everyone. Now let's move forward to the next. Alright. So now this question says ABCD is a quadrilateral in which PQRS are the midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that SR is parallel to AC and SR is half of AC. Now as we see from the diagonal bacha, the diagonal divides the triangle into two, the quadrilateral into two triangles. One is this one and the second one which we have is this triangle. Now let's see. In the very first part, in triangle ADC, Now in triangle ADC bacha, we can see that S and R are the midpoints. If S and R are the midpoints, S and R are midpoints. What we can say? S and R are midpoints. If they are midpoints, so we can say that SR is parallel to AC. Also SR is equals to half of AC by midpoint theorem. What we have done, bacha, that if S is midpoint of DA and R is midpoint of DC, so SR will be parallel to AC and SR will be half of AC. Now similarly in triangle BAC. Now in triangle BAC, if P and Q are the midpoints, P and Q are midpoints. And if P and Q are midpoints, what we can say? What we can say, if P and Q are midpoints, we can simply say that QP is parallel to AC and also we can say PQ, not QP. PQ is parallel to AC and PQ is equivalent to half of AC. Now PQ is parallel to AC, PQ is half of AC. Now see, if SR is parallel to AC and PQ is also parallel to AC, so we can simply, bacha, from here say that SR is also parallel to AC, to PQ. If SR is also equals to half of AC and PQ is also equal to half of AC, so from here we can say that SR is equals to PQ, and this is what asked in the question. No, we have done additional part, right? The first one was SR is parallel to AC and SR is half of AC. We have done that. The second one was PQ is equals to QR. PQ is equals to QR. And the next that we have is PQR is the parallelogram. Now see, we have proven that SR is parallel to PQ and SR is equivalent to PQ. Right? This is the first thing that we have, that SR is equals to PQ and SR is parallel to PQ. One thing we have done, right? That's correct. So what do we have now? And now the next thing that we have is PQ is equals to QR. Now this is again simple. It's a parallelogram because opposite sides are parallel. Right? Okay. Now the next thing is, see, again I'll tell you from this figure, bacha, what we have done. The very first thing, that F and R are the midpoints of DA and DC. If I join these 2 points, it will be parallel to the third side and it will be simply half of it. I hope that this thing is clear with everyone, right? Now the next thing that we have is simply, if P is the midpoint and Q is the midpoint, if I join this, and if this is the triangle that we are forming, so it is again half of this and parallel to this. I hope this question is clear with everyone, right? So let's move forward to the next one. Okay. Now the next question says, 3 angles of a quadrilateral are equal and the 4th angle is equivalent to 144 degree. Now, what does this question says, bacha? That we have a quadrilateral and in this quadrilateral 3 angles are equivalent to each other and the 4th angle measures 144 degrees. Simple. We know the angle sum property. We know that sum of all the angles of the quadrilateral is equivalent to 360 degree. So we know x plus x plus x is 3x and 144 will go over there as 360 minus 144 degree. Now we have this. So we have 3x is equals to 216 degree. Right? And x is equals to 206 divided by 3. So we have 3 7s are 21, 3 2s are 6. So the value of all the 3 angles that were equal to each other is 72 degrees. I hope that this thing is clear with everyone. Let's move forward to the next question. The next question over here says, if one angle of a parallelogram is 30 degree less than twice the smallest angle, find the measure of each angle. Now in such questions, people, what do we need? We need the properties of parallelogram. We need that adjacent angles are supplementary. We need that the opposite angles are equal. So let's say if one angle of a parallelogram is 30 degree less than twice the smallest angle. So let's say this is the smallest angle x. What we have taken? That let the smallest angle be x. So let's say the smallest angle is x. So the other angle will be 30 degree less than twice of the smallest angle. 30 degree less than twice the smallest angle. So we know if this is x, so this is also x. If this is 2x minus 30, so this angle will also be 2x minus 30. Yes or no? And we know that sum of all the angles of the quadrilateral is equivalent to 360 degrees. So what we can say that 2x minus 30 plus x plus 2x minus 30 is equivalent to 360 degree. So we have 2x plus x, 3x, 4x, 5x, 6x. So we have 6x minus 60 degree is equals to 360 degree. We have 6x is equals to 360 plus 60 degree. And we have 6x is equals to 420 degree. And from here, the value of x comes out as 70 degree. That means the smallest angle of the parallelogram is 70 degree. So this angle will be twice of 70 minus 30 degree. 140 minus 30 degree, that means 110 degrees. I hope that this thing is absolutely clear. Now let's jump to the next question. Now in this question again, it is specified that ABCD is a parallelogram. What do we know? That this ABCD that we have is a parallelogram in which ADC is 75. We know that the opposite angles of parallelograms are equal. So if this is 75, this will also be 75 degree. If this is x, this will also be x degree. So first of all, let's find out the value of x. So we know that x plus 75 degrees plus x plus 75 degree is equals to 360 degree. So we know that 2x plus 150 degree is equals to 360 degree. We know that 2x is equals to 360 minus 150 degree. 2x is equals to 0, 210 degree, and the value of x comes out as 105 degree. So what is the value of x? The value of x comes out as 105 degree. Now the next thing is, we got that this is 105 and this is also 105. We need to find the value of y as well. We know that this angle ABC plus y will be 180. Why bacha? Because of linear pair. So we simply know that 75 degree plus y will be 180 degree. The reason being they are forming linear pair. As simple as that. Now, y will be equals to 180 minus 75 degree and y will be equivalent to simple 105 degree. Now the last thing that we have to do in this particular question is find the value of x plus y. So simple, we have to find the value of x plus y, that will be simple 105 plus 105 and that will be giving you 210 degrees. So I hope that this question is absolutely clear with everyone. So this was all about the session. So let me give you a quick recap what we have done. So we have understood first of all the properties of quadrilateral. That what are quadrilaterals? Any polygon with four sides is known as quadrilateral. For example, a square, a parallelogram, a rectangle, a rhombus, a kite, a trapezium and everything. Now the next thing that we have learned about is the angle sum property of quadrilateral. That means all the angles of the quadrilateral adds up to 360 degrees. The next thing that we have learned about is about the midpoint theorem. So midpoint theorem states that if we have a triangle and for the two sides, if we have midpoint of those two sides and if we join the lines between those 2 points, so the line will be parallel to the third side and also will be half of it. We have learned about the converse, that if 2 points are there, if one is the midpoint and the line which we have drawn is parallel, so it will be the midpoint of the other line as well. And some related questions we have done, so that is what we have to practice. So I hope that everything from this chapter is absolutely clear. If you have any doubt, feel free to comment down, and we will meet in the very next lecture of another chapter. Till then, take care, have a great time ahead. Thank you so much.